Hello everyone and welcome. We're looking at our 2.1 ThatQuiz assignment. As you're logging into the ThatQuiz, make sure to find your name in the drop-down menu, and then you're just going to type in that password, all lowercase GCVS, and hit OK. And then you'll be logged in and we can get ourselves started here. This first question says, what kind of test can be used to determine whether the graph is a function? So if we want to know that this is a function, we can do our lovely, can I make a vertical line test? So what that means is we can draw a vertical line through the graph. Yeah, I was seeing if I had a straight line tool, something like that. And as long as it only hits the graph in one point, then we're good and we know that it is a function. So that is our vertical line test. Go ahead and hit OK. So this graph is a function. So if we think about the vertical line test, each vertical line that's drawn should only hit the graph in one place. So you can test it as many times as you need until you feel confident in saying, yeah, it only hits this graph in one place at each line. So this graph is a function is definitely going to be true. Nice job. Here is an absolute value function when we have these like V that are forms. And again, if we draw a line, it will only hit that graph in one place. We can check a couple spots if we want until we feel nice and confident. And yes, again, this is a function. This says determine whether this is a function or not. So if it's not a function, then what we're going to see is repeated x values. So when we're looking in this table, what we notice is that there's this x value of 3 and it's repeated twice. It's going to A and then it's also going to E. So these are two coordinates, 3 comma A and 3 comma E. So we have this repeated x value, which means this is not a function, because that 3 has 2 arrows going from it to 2 different outputs. Okay. Looking at this next one, 1 goes to 7 and only 7. 2 goes to 7 and only 7. 3 goes to -2. 4 goes to 8. And 5 goes to -9. So each of those lines, each of those inputs only have one output that they're being connected to. So this one is a function. That one passes the test. So we're looking for repeated x values. So if I see my x's, I see a -4, a -3, a -2, a -1, and a 0. And again, that's just my x values. And those are all different. So we're good. As long as there's no repeated x values, we have a function. So this one is a function, and then you can hit OK. A relation is a set of ordered pairs. So a relation is this relation that we have between our x and our y values. Sometimes it's a function, sometimes it's not, but it is a set of ordered pairs. Okay. Which of the following relations is a function? So we're looking for the ones that are not a function, which means we're going to have repeated x values. When we're writing coordinates, it's always x comma y. So we want to look at that first number to see if there's any repeated. So down at the bottom, I see 3 is repeated twice, so that is not a function. Then For option C, we see that 1 repeated 3 times, so that's not a function. And then we see 0 repeated twice, so that's not a function. Notice this first option, all of the x values are different, so we're good, and it is a function. Beautiful. Alrighty, so we're looking for those repeated x values here. So I notice we have these repeated 3s. Then we have these -1s that are repeated. We have these 5s. The only option is option A that does not have any repeated x values. So that one is a function. Is the relation depicted in this chart below a function? So look at the x values. Are there any repeats? Sometimes it helps to write them down again. 0, 1, 3, 5. Ooh, another 3. That's bad. That means we have a problem. But they're both going to 10. So they're not going to a different output. So that's okay if they're both going to the same thing. So this is a little tricky. This actually is a function. And again, that's because both of them are 3, 10. Those inputs have the same outputs, so that's okay. Which of the relations here is a function? Well, in the first one, we have a bunch of 2's repeated, so that's definitely not a function. And then we have a bunch of 0's repeated, also not a function. But if we look at this one, our x's are 1, 2, 3, 4, and 5. They're all different, so that is certainly a function. Consider this relation, 5, 2, 7, 4, 9, 10, and x, 5. Which value of x would make this a function? So we have a 5, we have a 7, and we have a 9. So we cannot have any of those again. So it can't be 5, can't be 7, and cannot be 9, which means the only number we have left that would work is 4. So you want to plug in 4 and hit OK. When we're talking about the domain of the function, remember that domain is all of our possible inputs or x values, and we put them from least to greatest is when we're writing them. So looking, and usually they're written least to greatest already, so it makes it nice and easy. Here's our inputs on the left, outputs are on the right. So our smallest is -3, then -2, then -1, and then 0. And that's all of the domain, those 4 points. So for this one, this is looking for the range. Now the range is similar, lowest to greatest, but these are just our y values or our outputs. So we're looking over here at 12, 13, 14, 15. That's it. Then hit OK. This is asking for the domain. We look over here. We remember that domain is our x values. So we're just listing those x values in order, least to greatest. So we start with a 0, then a 2, then a 4, then a 6, and then an 8. And then for the next one, on the next slide, it's looking for our range, which is our y values, lowest to greatest. And we don't put any repeats. So here we have a 4, that's our smallest. There's 2 6s, we only have to write it once. And there's 2 8s, so we're just going to write that once as well. We don't have to put any repeats, okay? And when you're all set, go ahead to the next slide. And this one is asking for the domain, which is our x values. We have two x values here, just 8 and 9. So that's our domain, 8 and 9. And our range for the next one, we have on the right a -3, a -4, a -6, and a -9. So smallest to greatest, we start with -9, -6, -4, and -3. And then hit OK when you're ready. This next one's looking for the domain, so we're looking at our x values, smallest to greatest. I see a 0 as our smallest, a 1, and a 2. So here's my 0, I got that. I got these 1s, I only had to put it once, but I got that, and then we have these 2s. Perfect. That's our domain. And the range, smallest to greatest, 4, 5, 6, 7, 8. Perfect. Nice and in order as written. And then hit OK when you're ready. The range for this one, we're looking at our y values. So here's our y axis. And we're going to focus on these points. And we're going to get their y value. So our lowest point is right here at a -2. Okay. And then we have these 2 points are both at a 1 y value. And then this point up here is at a 5. So altogether, we have -2, 1, and 5. And then hit OK. And using this next graph, thinking about domain. So domain is our x values. So at this point, our x value is 1. At this point, it's 2. Then we have 3. Then we have 4. And then we have 5 for our points. So we started with a 1, 2, 3, 4, and 5. And then hit OK and finish. Beautiful. So once you're all set with that, great timing here, you can submit that into Schoology. Let me know if you have any trouble, and I will see you all in the next video. Take care, friends. Nice work.